Hello ladies and gentlemen, welcome to this video. Your best online tutor, previous the tutor. And in this video I've got some examination questions which I want to do with you. And if you find this video to be helpful, you can leave a subscription. And you can also follow me on Facebook as well as on TikTok. You can also start your online classes. If you are writing your GCE or your G12, we'll be there to help you. Or answer all the questions provided and so on. So I've got about 5 questions. Let's dig into the questions. When converted to a base unit in scientific notation, 2 GB is what? Now 2 GB is 2 gigabyte, and when you talk of and the word giga, all right, means 10 to the power 9. So the word here G means 10 to the power 9. Then you got the what? B is for byte. Alright, so when you say 2 GB, we mean 2 times 10 to the power 9 GB, which is bytes, which is D. It's D, eh? Question 2 says, which of the following is a derived unity? Now, a derived unity is a unit which is formed when you combine 2 or more base or basic units. Ampere is a base unit, Kelvin is a base unit, meter is a base unit. These 3, they are base units. Only a Pascal. Remember that a Pascal is a Newton per meter squared. This is a combination of a Newton and a meter. All right. So our answer there is is D. A car moving at 3 meters per second increased its velocity uniformly to 9 meters per second in 4 seconds. Find the uniform acceleration of the car. So we've got our initial velocity is 3 meters per second. Our final velocity is 9 meters per second. Our time taken is 4 seconds. How do we find acceleration? So acceleration is equal to change in velocity over change in time. So change in velocity to be v minus u over t. We've got 9 minus 3 over 4. What do we get here? We get 6, right? Over 4, which is 3 over 2, which is 1.5 meters per second squared. This should be an answer. Alright, we move on to another question. A lock weighed 8 Newton on the moon, where the acceleration due to gravity is 1.6 Newton per kg. Calculate the mass of the lock on Earth, where the force of gravity is 10 Newton per kg. Alright, so on the moon and on Earth. So on moon, they are saying the weight was 8 newtons, and the gravity here, it's 1.6 Newton per kg. They're asking us to find the weight on Earth, all right, whose gravity is 10 Newton per kg. So there are 2 different ways of answering this question. That is if you are clever. All right. The other way is you've seen this, where we are looking for the mass, right? So we can say if 1.6 gravity is giving us a weight of 8, what of a gravity of 10? What weight will it give us? So you can now say 8 times 10 is 80. You divide by 1.6, you get 50 newtons. This is on what? On Earth. But the question is asking you to find the mass. The mass, remember that weight is equal to mass times gravity. So here where there's weight, we put what? 50. And the gravity there is 10, 9 times what? M. So we divide both sides. So mass is equal to 5 kg. There. Alright. The other way around is easy. Remember that mass does not change. So if you find the mass from here, it will be the same mass that we're going to use there. Another way that we can do this is this. Another way is, since we've been given weight and gravity here, we can find mass. Mass is equal to weight over gravity. The weight is 8, the gravity is 1.6. So we have 8 over 1.6. It's giving me 5 kg. Now we know that mass does not change. It doesn't matter which place you go to, mass does not change. So mass on moon is 5 kg. That means even mass on earth is still 5 kg. So you are still getting the same. Like I said, you can use this the two-way depending which one you are comfortable with. The following diagram shows a pilot in air after jumping from a plane. So this is a pilot after jumping on a plane. As he falls, how will the size of the forces acting on him change before he attains terminal velocity? Now, I want you to take note of this word called terminal velocity. All right, so terminal velocity, I'll explain it here. Terminal velocity is just the velocity, all right? I would say it's a maximum velocity attained when the upward force balances the downward forces. So the way this one is dropping down, so you find that the force acting up balances the force acting down. So that velocity is a constant velocity. That means there is no change in velocity. It's constant. It means acceleration is also zero because there's no change in velocity. So this force here, which is acting down, and this force which is acting up, when they balance, that velocity which is at 10, we call it terminal velocity. Now, what happens to the size of the forces acting on this one? So we've got the downward force and the upward force. So what you need to know is that the downward force, it will always do what? Decrease, so that this one can balance it up a bit up there. So this one, the downward force decreases. All right, then the upward force increases. Now once this happens, all right, there is therefore a decrease in the resultant force. So therefore the resultant force does what? Decreases. So our answer is what? C. All right, now just another explanation there. When you talk of the downward force, of course we're talking of gravity. All right, and gravity is, we know that it remains constant, and but as this parachutist is falling, this downward force, which is gravity, it will never change because it's constant. But the upward force, it can be air resistance. All right, now air resistance, when it's pushing you up, it's increasing because the other force is constant. All right, so the other force is decreasing, but the other force is what? Increasing, which is the air resistance, and the resultant force will also decrease. Well, I hope you enjoyed the video. Like I said, subscribe please.